Florida's peninsula geometry is a stage for coastal convergence. During summer, the land heats rapidly, drawing air inward from both coasts. The resulting collision zone becomes a favorite birthplace of storms. Terrain plays a supporting role. The gentle slopes and lakes like Okeechobee help modulate circulation, providing low-level vorticity and moisture pooling, enhancing convergence inland. Meanwhile, the Atlantic's tropical monsoon climate ensures the air mass is always near saturation, amplifying the tendency for vigorous afternoon storms when even modest lifting is introduced. South Florida, Miami region. This morning, a peeling, decaying frontal boundary lingers to our north in the Florida Panhandle. At upper levels, a broad ridge over central Florida is gently eroding, yielding to an approaching disturbance in the western Atlantic and Bahamas, hinting at more organized moisture and lift ahead. The pressure field remains slack, and surface winds are light and variable. Such slack winds grant dominion to our trusted sea breezes, both along the Atlantic and Gulf coasts as they push inland. In the interior, where these breezes collide, convergence ignites afternoon convection. Rain chances soar. Point probabilities of precipitation rising into the 80 to 90% range by Friday afternoon. These convective outbreaks will act as atmospheric safety valves, tempering daytime heating via cloud cover and latent heat release, nudging temperatures down into the low 90s, remarkably enough to forestall heat advisory thresholds. Meanwhile, humidity remains robust, with precipitable water values exceeding 2 inches, indicating the potential for heavy rain and rapidly developing storms. In past days, deeper ridging and sparse upper-level support resulted in widespread heating and elevated heat indices, soaring into the 105 to 110 degrees Fahrenheit range, prompting advisories. Today, however, the narrative gently shifts. More showers, somewhat lower thermal stress, but still a muggy, energetic sky eager to thunder. For aviators, these convective cells, not to mention outflow boundaries, represent gusty surprise wind shifts, lightning, and downdrafts. Visibilities may fall into MVFR or even IFR within storms. Pilots should remain alert for sudden TTL turbulence as sea breeze collisions spark clusters inland. Macro scale view, the bigger picture. Zooming out, the southeast is under a typical midsummer regime, a decayed front parked to the north, while high pressure resides offshore. Aloft, a slowly migrating upper impulse, a mid to upper level trough extending southeast, is providing just enough dynamical nudges to favor convection without sweeping in a full frontal overhaul. This pattern supports diurnal moisture-fueled storms, winning the day through boundary interactions rather than large-scale frontal lift. This is the textbook Florida pattern. Sea breezes clinch the trigger, backed by humid, unstable air and minimal synoptic steering. An elegant convection ballet driven by local geography and thermodynamics, all set against the humid monsoon backdrop typical of South Florida summers.